Welcome back, everybody. Solving another trig equation. Notice that this one says we're going from 0 to 2 pi, so that means we're using radians. And then usually I solve the problem and then graph it, but this time I'm going to switch it up a little bit and take a look at the graph first, because I want to know how many solutions are we supposed to be looking for. So the red line is the right side of the equation, that just equals 1, and then of course the green wavy one is the left side of the equation. So they intersect in 1, 2, 3, 4 places. So we're looking for 4 solutions. So usually with an equation like this, I would solve for sign and then use square root, remembering to do plus and minus square root. But this time I think I'm going to do it a little bit different. So first of all, notice that a 3 can be factored out. So if I factor out a 3, it would leave 1 minus 2 sine squared of x equals 1. Then I can divide both sides by 3, and the left side would still have the 1 minus 2 sine squared of x, and now it equals 1/3. Then, for this particular problem, notice that this 1 minus 2 sine squared, that's equal to cosine of 2x. So not only does that method simplify the problem, but it also explains why we're looking for 4 solutions. Because this little 2 right here means look for twice as many solutions as usual, excuse me. All right, now to eliminate cosine, take cosine inverse of both sides. And we would have 2x equals cosine inverse of 1/3. And if you take a look at just the graph of cosine, so this line right here is saying if you look at the cosine function, when does it equal 1/3? So that would be right here. And when we do cosine inverse, it's going to tell us that first answer. And the other one would be right here. And since over here is 2 pi, that means this second one is going to be 2 pi minus whatever we got from the cosine inverse. Okay, so now let's actually do that. So if you bring up my little cosine inverse, you'll see that cosine inverse is equal to a 1.23. So right here we have a 1.231, and then this other side will be 2 pi minus 1.231. And bringing up my little calculator, that means this other one is 5.052. Okay, so we've got these two. Now keep in mind that still is what 2x equals. So then move down to the next page, and we've got 2x equals 1.231, and also 2x equals 5.052. So since we're supposed to find 4 answers, what we would need to do is follow this graph out for another cycle. Okay, that is very sloppy, sorry about that. Anyway, if you followed out for another cycle, that means you're adding another 2 pi. So to each one of these, we just need to add 2 pi. Now it's important that you do not divide by 2 right here until the very end. So find your first two solutions. If you need 2 more solutions, then add 2 pi, and they will all say 2x equals. And then as a very last step, I will divide by 2 on all of them. All right, then I need a little calculator. And a little bit bigger. So there's the 1, there's the, there's the 1.231, there's the 5.052. Now take each one of those and add 2 pi, add 2 pi. So then we get 7.514 and 11.335. All right, the last thing to do is divide by 2 on all of those. So when I do that on my little calculator right here, I finally get x equals 0.615, x equals 2.526, here's the third one, and the last one. And notice that all of these are between 0 and 2 pi because 2 pi is 6.28. So even the 5.668 is still within 0 to 2 pi. And now the last thing to do is take a look at the graph of the original function. And I use Desmos for this one because Desmos allows me to not only graph the original, but then I just click on these points. So I just click on the point on Desmos, and then it shows you the point and it shows you the solution. This one is correct, 2.526, 3.7, yes, and the last one is correct. What a great day.